You got the roots for the graph, and that's actually what we're maybe doing today, but we're probably going to be doing next class. And what you needed to do here, well, if you have a calculator, it's easy peasy. You just plug it in and figure out what goes where. If you don't, I'm going to show you the process here, and I'm going to show you it a bunch more times. Basically, to find the roots, you set y equal to 0. Because remember, the x-axis, that's where the roots are. The equation of that is y equals 0. So you set this equal to 0, and then you're going to factor this. Remember the last unit I said this factoring is a big deal, we're going to be using it a lot. This is one of those spots that we're going to factor. So I'm going to talk my way through this just so you see it, and I'll show you that extra step here. It's not going to be the most important thing, but it'll help you out here. So this tells me that I have a plus and a minus in my parentheses. The signs are different. This tells me the bigger one's a negative. So I have 0 equals 2 sets of parentheses, x plus and x minus, okay? And I'll list out my factors of 12. I know that I have, and the bigger one's going to have a negative, so I'm going to do 1 and negative 12, 2 and negative 6, 3 and negative 4. And I want the ones that add up to negative 4, and that's going to be 2 minus 6. So I do 2 and 6. Now, where last unit you were done, now you're not done. Now you have to take it to the next level, and that would be setting each one of these factors equal to 0 and solving it. So it's going to kind of flip your signs eventually. So I've got x plus 2 equals 0, and x minus 6 equals 0. Subtract 2, so I get x equals negative 2, add 6, so x equals 6. So without using my calculator, I found that my roots are negative 2 and positive 6. Once again, that's what we're probably going to be practicing on the first lesson next week. That's what we got going on there. All right. All right, so next one is the vertex. Once again, if you have your calculators, pretty quick. If you don't, you can do the x equals negative b over 2a. And that would give me negative 4 over 2 times negative 1. That's going to give me negative 2, and then plug negative 2 into that to get the 4. That's the way it would work. Okay, so there's ways of doing this without the calculator. Calculator makes your life infinitely easier, but that's what you got going on here. And then the next one, number 3, I don't have an answer there, do I? I need to find a calculator and find out what the square root of 7 is rounded to the nearest hundredth, because this is an exact answer. This is actually the best answer you could have here, but it says round answers to the nearest hundredth. And you know how we get when we don't do what we're supposed to be doing. And, oh, hold on a second. Escape. So, I don't know whether you can see that or not, but no, you can't. There we go. No worries. Calculators can't lie. So don't worry about what's going on. We got this. We're going to get better at it. Life is good. We can do this and get her done. Okay, so I need to get the square root of 7 and enter, and it looks like 2.64 blah, 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 blah. Now if I round that to the nearest hundredth, it would be 2.65. Once again, it's a plus or a minus. Whenever you take a square root, it could be positive or negative. Okay. And then sliding on down, I think we see the rest of that, and that was the homework. Okay, so now we're going to kind of move forward. I hope that you watched this and filled it in, especially those that did delta, because this has got a little bit more information than you learned on the delta. The delta was just graphing with a couple of minor questions. Roots, vertices, axis of symmetry, big important information that you need to get down. Okay, so let's go through a couple more questions on this one on page 16. Once again, on the last class, I said pages 16 through, or pages 1 through 20 are going to be part of what we have going on here. And then the next lessons next week, I'll put the next section of the packet on for you. You can print what you want or take notes on what you want. Okay, so this is, and we're going to see some e-math instruction stuff coming up too. Any function that can be placed that's once again standard form of a quadratic equation, which gives you a parabola. And B and C can, but B and C can be, okay, you can't have A equals 0 because then it turns into a line. These two don't need to be there. All right. All right, leading coefficient has to be non-zero because it would be a line. It would become a line. The next one is a weird question. It said, circle the choices that are quadratic equations. Now, quadratic equations basically are the highest exponent is an x squared with no weird stuff on it. Okay, so this is a quadratic equation. That's got an x to the third, so that's not. This one looks like a quadratic equation, but that square root thing says nope. And then this one is a quadratic equation. Even though it's not in standard form, it's a quadratic equation. So A and D. All right, and then they want us to write something in standard form. I think we've gotten that down, but we'll do this just for, fun. We get y equals negative 3x squared plus 7x plus 10. Okay, once again, the negative was on the 3x squared, so that came to the front, and then the others. And then the last one says find, okay, without using your calculator, find the value of negative 2. What point must lie on the quadratic graph for this calculation? Oh, okay. They just want you to plug in a negative 2, and you could use your calculator if you want. I'll do it without it. 2 parentheses negative 2 squared minus 3 times negative 2 plus 1. So that's going to be positive 4 times 2 is 8. And then negative times a negative is a positive. 3 times 2 is 6 plus 1. And that's going to give me, I almost said 17. That's going to give me 15. And this is a weird question, and lots of people don't, they look at it and go, what are they asking me here? Well, basically they're saying, well, this was our x, this is now our y, so the point that's on the graph is negative 2, 15. That's all they're asking. Okay? So, complicated words, simple answer. All right, so let's go over to page 17, and this is going to be the real basis for this lesson. All right? And let me slide it back so you can see it all. And it says, using your calculator, generate a table and graph for the parabola on the given grid. Okay, show a table of values that you use to create a plot. So we're going to basically type this in our calculator and get a list of values. Once again, if we didn't have our calculator, we could still do this. You'd have to do your negative b over 2a and then do some points on either side of it. They give us 7 points here, so we're going to want the vertex in the middle. Okay, that's really important. It keeps this thing. All right, and let's see what happens when I put this in the calculator. And let me go here. It's going to take me a second because I forgot I had to do this. And I'm going to do x squared minus 2x, not negative 2x, minus 2x, minus 8. I hit enter, and it gives me that. All right, and that's, I can get some points out of it. If I look carefully, I can pick out my roots, okay? Well, let's just go to our table, and when you look at your table, Control T, you're looking for that low point, okay? So if I look at this, starting here at 0, 4, or 4, 0 rather, and it goes negative 5, negative 8, negative 9, negative 8. So you can see that it goes down to negative 9 and starts coming back up the other side. That makes 1, negative 9 my vertex. Negative 9 in the middle of my table, and I'm going to count backwards from there. I'm going to do 0, negative 1, negative 2, and then I'm going to do 2, 3, 4. All right, and then I can fill in for my table. This is negative 8, this is negative 5, and this is 0, so that's going to be a root. And this is going to be negative 8, and negative 5, and 0. And 2 ways of knowing that. I could just slide up in my table, or I can remember that it's got that symmetry thing going on. All right, so it asked me, what is the range of this function? Well, let me finish graphing it first. That's probably a good idea. All right, so I go 1, negative 9, 0 and 2, negative 8, 3 and negative 1, negative 5, and then to my zeros. connect my dots, round bottom, not V bottom. Yeah, I know, I say it over and over again. All right. And I put arrows on this because they didn't limit my domain anywhere here. So that's what I got going on. So I have an arrow there. And let's see what else we got going on. So are they going to ask me about that? They asked me about the turning point. They asked me about the axis of symmetry. They didn't ask me about the roots. Well, we'll add the roots in here when we go through our discussion. All right, so it says, what is the range? So range is the y values. All right, so I'm going to show you how to do, I'm going to do it a couple of different ways, just reminders, okay? So the range is going to be, this is the deluxe set builder notation, y such that, and you want to have a range of values. The lowest value I see for y is right here at -9, -9. I have -9, and it's a solid dot there, so I do a less than or equal to, and then I put my y, and then up here we got arrows, so that means it's going forever, you know, to infinity and beyond. I do this thing, and I do an infinity symbol, and then I end my swirly bracket. Okay, or if you really want to be simple about it, this would actually be totally correct. Y is greater than or equal to -9. This and this say the exact same thing. This one's a little bit more detailed, but that one does it as well. And then interval notation, remember it's a square bracket at -9, and then your infinity, a rounded bracket. Okay, so those are the three ways of doing it. All of those would be correct. So that was range. Now they want a domain interval that's increasing. So if you remember with slopes, when you had a slope that went up from left to right, it was positive. If it went down from left to right, it was negative. So this is called increasing. And this is called decreasing. Okay? So we want an interval, okay, that it's increasing. So we want to be this side, okay, because it's going up from left to right. That's what we're looking for. So we're going to say it's got to be an X. Now, right here down at the bottom, technically it's not increasing or decreasing. It's that turning point. It's that change in direction at our minimum. So we can't include that point. So we don't want to put a line underneath this inequality sign. So we're just going to say X is greater than 1. Okay, X is greater than 1, then it's going to be increasing. Okay, if we want a decreasing, you just change that and flip it to X is less than 1. But you're doing the X values. The common mistake here is to say X is greater than -9. Not true, that's a Y value. Okay, and these increasing and decreasing intervals have something in common. They have to do with the X value of the vertex. Very important that you get that you notice that. And the other thing that you can notice is that the range has to do with the Y value of the vertex. Okay, so those are very important points, just like the roots will also be an important point. It says state the coordinates of the parabola's turning point, also known as the vertex or the minimum point, and we just talked about that a second ago. That's going to be 1, -9. Okay, so it says draw the axis of symmetry and write the equation of the axis of symmetry. So the axis of symmetry, once again, we want to put it as a dotted line, and it's going to right through the vertex, and that's going to be X equals 1. I don't want to do a -1. I don't know why I got a -1 on my brain this morning. Okay, so that's that. Then it says, what are the x-intercepts of this function, also known as the zeros? Why does this name make sense? Well, because that's where y equals 0. It is where y equals 0. Okay, and that would be here and here. You kind of notice I kind of coordinated. I got zeros, okay, I got squares, and now I got triangles. So my roots and are going to be at -9 2 comma 0 and 4 comma 0. But once again, when you're stating roots, you don't state them as points, you state them as a set, -2 comma 4. All right. Now, I have one more question I need to ask here, and this is an important one. So my new question is going to be, when is f of x less than 0? Or negative? Okay, so what is that question asking? Okay, an important question here. We want to know, when is the function, the output, less than 0 or negative? So we're looking at down here. Okay, that's what we're looking at. We want to find the range of these values when it's going to be less than 0. So we're going to be stating this in terms of x. So it's going to be in terms of x. And this is a popular question, and here's what you're going to find out. It has to do with your roots. So if you look at it, from -2 all the way up to +4, it's below the x-axis, which means it's negative. Remember, this is negative. Negative y, and this is positive y. Okay, well, can't really see that well. We'll slide down, negative and positive. All right, so I'm looking at these roots. So I'm going to bring down my -2, and I'm going to bring down my 4. I'm going to put an x in the middle. But here's what you have to remember. Where it hits the axis, it's a 0. Okay, so this is -2, 0, and +4, 0. That's not negative. So when you go to do this, you don't do it with a line underneath it. It's got to be this way. All right, or if you're doing it in interval notation, it would be -2 comma 4. Okay, so that's what we have going on here, and I think that answers most of my questions. Hold on just a second. Okay, I am going to talk my way through page 18. Your homework assignment is going to be pages 19 and 20, and I'll post those separately on Classroom for you. And I'll see if I can find a Delta assignment that matches it, but I'm not sure I'm going to be able to do that. I'm just going to go through this page and see what we got going on. All right, so here we go. It says the quadratic function f of x has selected values shown in the table below. So that's the table over here. Okay. And we want to find the coordinates of the turning point. So you look at it, it's going up, 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 and then starts going down. So right here is my change in direction. That's going to be 2 comma 13. Now, this says that it has selected values. That means that it stops here and it stops here. All right, that's going to be important for us. So it says, what is the range for this particular function? So we're going to look for the highest y and the low y. Okay, and here's where a lot of people get into trouble. You're used to a linear equation where this would be the lowest one and this would be the highest one. That's not what's going on here. The range has to do with the lowest y value right there. That's at -2. And once again, this is going to be a y. And the highest y value is here at the vertex. That's going to be at 13. Okay? And these include those numbers, so it's going to be a less than or equal to and a less than or equal to. If they ask for the range or for the domain of the function, domain, just to make sure we're on the same page, that goes from -1 less than or equal to x less than or equal to 6, because it just says the selected values for the function, so that's where it goes from. Okay, that's that one. Now we get some multiple choice. Okay, no like circling number 3 because that's your favorite number. All right, so which of the following is a quadratic equation? That means only one of them will be quadratic. Once again, quadratic has an ax squared in it as its highest exponent. And this is a line. This is a cubic. This is an exponential function. And this is our correct answer. Okay, a little bit of extra information there for you, because they could just change this question, change that from quadratic to linear, and you'd be picking that one. Quadratic to cubic, and it'll be that one. We'll be studying cubic equations a little bit in our next unit. Hopefully I'll be standing in front of you by then. And we'd already done exponential functions. We did them last unit. Actually, the unit before last. All right, and now we want to do things in standard form. So we want to get the x squared in the front, and it's a negative x squared. That means I can get rid of this one and this one. And then I got a plus 4x right there. So it's going to be choice 1, not choice 4. Okay. And number 3, what is the leading coefficient? Okay, so the leading coefficient has to be attached to the highest exponent. So it's going to be right there. So it's going to be positive 7. And it says, which of the following points lies on the graph of x squared minus 5? All right, so, what are you going to do? Plug in numbers. Well, I'm going to plug in the easy ones first. So if I do 5 squared, I get 25. Minus 5 is not 0, so that one goes out. If I do 3 squared, I get 9, and 9 minus 5 is 4, so that one's out. This isn't going very well. I like negative 1 better. So if I do negative 1 squared minus 5, ooh, they're tricky. Negative 1 squared is positive 1 minus 5 equals negative 4. And that hopefully means that negative 2, negative 1 will work. And if I do negative 2 squared, that's positive 4 minus 5 equals negative 1. Ta-da! All right, and then the last one. Quadratic function is partially given in the table. Which of the following are coordinates of its turning point? Right there. Okay, so you see some ways to do that. We're looking for that low point or high point. There's my low point. And you got your work cut out for you. I think that's the right answer. Yeah, okay. And pages 19 and 20 for homework. Once again, if I do find a delta assignment to work with, we will work through that. Thank you very much.